Hello everyone, welcome to this next session which is called as Awake program. See, in this program we'll try to help you with the mains examination, and all of those who are taking mains examination this year, they must be in the final stage of their preparation. So it is one of our attempt to help you with the answer writing mainly, and to strengthen some of your concepts if there are some weaker concepts. So in this session we'll be talking about the physical geography mainly, and subsequently we'll go for other sessions and other topics. As of now, this program is mainly focused on answer writing. This program mainly focuses on what are we supposed to write and what are the different dimensions of a subject and a particular topic. So here we will be starting with geography, right? Today, first session that we have is related to geography and the physical geography mainly. If you see your previous year question papers and going by the UPSC trends, there are 2 questions from physical geography at least. Sometimes it can be 3 questions as well from physical geography. If we see to 2013 and 14 questions, number of questions from the physical geography were many. It were like 5 to 6 questions from physical geography. Today, I mean these days, the number of questions from physical geography are limited to 2 or 3. But I must tell you, these concepts which are asked in physical geography, they are quite challenging in a way. They are not so simple as they were asked in 2013 and 14. For example, in 13 we had a question called as, which was first question, what do you understand by continental drift, and give the evidences of continental drift. But now, few years ago, 2 years ago, there was a question asked about mantle plumes. What are mantle plumes and how it helps in the plate movement and plate tectonics. In another similar type of questions which demanded a deeper understanding of the topic was asked on air masses. What are air masses and how do they affect the macroclimatic changes? Then the question asked on salinity difference and salinity variation. Account for the salinity variation and its effect on other aspects as well, other aspects such as multi-dimensional effect that was asked. So nowadays we see the question have reduced, number of questions in physical geography have reduced, but the level of question, the toughness of the question has increased. So they are relatively on a tougher side, the questions on physical geography, relatively on a tougher side. So we are going to start with the same today, physical geography. It will be a discussion on few topics of climate geomorphology first, and there will be discussion on climatology based topics or questions, and then we'll go to the discussion on oceans and oceanography, right? So let's start with this, and welcome to all of you with this this program which we are focusing on answer writing and knowledge enrichment program. So the question is, we are starting with taking this session with a question answer format. So we'll discuss few questions and related to that some dimensions and what are we supposed to write in that question. So the first question is, explain volcano formation, their types, structures associated with it, along with relevant examples. Now there is a particular reason we chose volcano. There have been questions asked on plate tectonics, there were questions asked on continental drift, there have been questions asked on thousands of archipelagos formed in Philippines and Indonesian region. These questions have already been asked. Question has been asked on old fold mountains, young fold mountains also. Why young fold mountains are located at the continental margins? So we expect that volcanism is one of the questions that has not been specifically asked, although it has been indirectly asked. No direct question on volcano has been asked as of now. So considering that, we are starting with the first question on volcano. What is explain volcano formation and all that. Now to understand the question, let's go back a bit and let's try to understand what are the concepts required to understand or answer this question. We should have an idea about, number one, the internal structure of Earth, right? Then we should also have a question, information on plate movements, or which is the theory of plate tectonics. The plate movement should be clear to all of us. And related to that, plate tectonics, right? How it moves and all that. Then a bit about, because examples have been asked, so examples like name of some volcanoes, etc. should be clear to all of us. And effects or influence of volcanism overall, right? Influence of volcanism. And then we'll see what other questions can be asked from here. Okay, let's go back to the question, explain volcano formation and the types. So when we go for the volcano formation, what is a volcano? First, let's try to collect various points, right? Let's try to structure this and then we'll write introduction and then conclusion for the topic. First of all, volcano is a vent through which magma comes out, right? That's all. It's just a vent through which magma comes out. So there should be one line about it. And the process of volcanic formation, volcanic eruption, is called as volcanism. A broader term which includes the processes that lead to the formation of volcanoes, a term that explains how volcano is formed and so on. And then we have their types. Then this is first aspect. Now it asks the volcano formation. That means we have to explain a bit about processes. What is the process of this volcanic eruption? And to explain the process of eruption, we need to understand the plate movement a bit and understand the plate tectonics a bit. So what happens here is that the two plates can diverge. A divergent plate is convergent at the other end. So suppose there is divergence at this margin, plates diverge here. So divergence at one end leads to the convergence of plates at the other end, or plate margin at the other end. And due to convergence, the relatively denser plate, which is mainly the plate that is composed of sigma, that is oceanic plate. So it subducts. So continental plate converges and gets to the oceanic plate, and oceanic plate being denser as it is composed of silica and magnesium, it subducts. Due to subduction, there is huge amount of friction that is produced, and the subduction zone is called as Benioff zone. The subduction zone is called as Benioff zone, and there is friction produced here, and due to that friction, heat is produced, and ultimately that leads to the formation of magma. So it melts, melting of oceanic crust, and that leads to the formation of magma, which erupts, and due to that eruption, right, volcanoes are formed along these plate margins. Volcanoes are formed along the plate margins. Which plate margin? We have convergent plate, convergence between continental and oceanic plates. Whereas at the place of divergence, along the plates of divergence, there is expansion, and expansion happens because these are hot molten rocks called as plumes. Since they come from the mantle, they're called as mantle plumes, right? Plumes result in divergence, and that divergence is the reason for the volcanic outburst or volcanic eruption at the divergent plate boundaries. So there are two conditions in which volcanism or volcanic eruptions take place. One is the divergence, another is the convergence. But we need to write it in one go, like explain the divergence boundaries and convergent boundaries. So this is the process that leads to the formation of volcanic eruptions. All right, and then we have the second part of the question, which talks about their types and structures and associated with it. Okay, let's try to write answer on this. What should we be writing in the answers, and how to relate these concepts in minimum words, right? So this is the process. I hope all of you understand. Of course, we understand we are taking mains this year, so we expect you to understand and remember these concepts, right, of convergence, divergence, plate movement overall. Now, how do we put it in our answer? How do we write in our answer? So first question is about definition should be there, because the question has been asked on the explain volcano, formation of volcano. So we'll start with the definition of volcano, and in the introduction, one should always try to summarize the entire answer in the introduction itself. Summarize the entire answer. To summarize the entire answer, what we need to do here, we put the definition here, that is a vent through which magma comes out, is referred as a volcano, which is an outcome of dynamic processes taking place on the surface of Earth. Dynamic processes taking place on the surface of Earth. Now, this kind of first line, where we talk about the dynamism of Earth's surface or the dynamic processes that take place on the surface. Besides this, now we'll move to the Earth's surface. Now we are connecting it to the plate tectonics. And this is my suggestion, that you cannot write everything about plate tectonics in 200 words. Explaining everything in 200 words becomes really, really tough. And we can't leave that also. We have to ensure that every point is mentioned there. So going by that, how do we connect this part, this plate tectonics part here? So we'll write, as we have written this dynamic process on the surface of Earth, let's try about surface of Earth. Now, taking a thread from here, taking one point from here, we write that the surface is divided in, or lithospheric plates, lithosphere of Earth has got divided in many fragments called as plates which slide over asthenosphere right, which slide over asthenosphere due to semi-molten nature, energized by, full stop, these are energized by convective currents generated deep inside asthenosphere due to decay of radioactive elements. Full stop. Now, this might look like a very long definition, but you see it summarizes almost everything. So, this is how I would suggest that some keywords should be mentioned. Now, what are the keywords that summarizes everything here? So, if you focus on lithospheric fragments called as plates, so here we are mentioning lithosphere and plates. That plates are nothing but the lithospheric fragments which are sliding over. They are not like, it's like slide over asthenosphere. They are not continuously floating over it. The slide movement, right, due to the semi-molten nature, convective current, decay of radioactive elements. Now, if you pick these 4 to 5 words, you can summarize the entire plate tectonics. If you focus on these 4 to 5 words, of course, framing of sentence can be different for everyone, right? Everyone has their own way of writing, but this is one of the definition that summarizes. Now, we don't have to explain plate tectonics again and again, that there are this plate, that plate and all that. Just memorize this or pick these keywords. Remember these keywords. If a question is asked here, you have to have these keywords in your answer, and that will save our words. Anyways, so this is how we introduce plate movement or plate tectonics here. So, definition, introduction. In the next paragraph, we are going to write about the lithospheric plates and all that. Now, the time to hit the question again, the process is, question asks about the formation of volcanoes. So, we'll write one line, one word connecting volcano with the plate movement. We know that it's plate movement. We use this thread of surface of earth mentioning the lithosphere and lithospheric plates. Now, we need to develop one more connectivity. What is that? We'll write that the distribution of volcano or volcanoes along plate boundaries, such as Pacific Ring of Fire, and mid-continental or mid-oceanic ridges. Even if you are not writing Pacific Ring of Fire or mid-oceanic ridges, no problems at all. But you must write the distribution of volcanoes along the plate boundaries. Now, what happens is, distribution around plate boundaries indicates, or its association indicates its association with plate movement. We are putting plate movement here, and then we'll write along. Now the answer is quite simple. Now we'll write in the next aspect. You can draw such diagrams, the diagrams that we have drawn. I'll tell you how to draw this particular diagram also. And then we'll write about along the convergent boundaries, what happens in the convergent boundary, what happens along the divergent boundaries, not wasting many words. That along the convergent boundaries, plates subduct, and subduction of plate leads to the formation of magma, which comes out, and at the same time divergence happens. A divergence at the opposite end, divergence is because of the mantle plume rising to the surface, and that creates this eruption of lava, right, from deep parts of asthenosphere. Now, drawing diagrams, some students draw a separate diagram for convergent boundaries, a separate diagram for divergent boundaries. I would rather suggest that you draw one diagram summarizing everything, because you don't have so much of time in exam to write everything, right? Draw. So what we can draw, and make sure that you draw such, try to draw these 3D diagrams and all, and practice a bit. It's not something very difficult to do. In one line itself, in one paragraph, right, showing that subduction, and here this asthenosphere. So you can show the melting, or you need not write oceanic, you just write Sima, you just write Sial, and here. Now, when you are showing this diagram, make sure that you show these convective currents also. That would be a self-explanatory diagram, right? Showing that the mantle plumes, they are rising. These are convective currents rising from the surface, and here there is divergence of the plate leading to volcanic eruptions, a convergence of the plate leading to the volcanic eruptions again. So here they are also called as constructive plate boundaries, and these are called as destructive plate boundaries. I can understand that it takes some time to practice this particular point. It takes some time to write all these aspects, all these dimensions in one go, but then you try to draw such diagrams. Okay, now we'll address the second part of the question, which says, now it is easy, the types, structures associated with it, and relevant examples. What are the types of volcanoes? You know, there is one way of defining volcanoes as active volcano, dormant volcano, extinct volcano, right? This is also one of them. Active volcano is the one which erupts very frequently. Dormant is the one which has erupted once in the human history, but is not very frequent. And then we have extinct volcano, which has erupted somewhere in the past and does not show any signs of eruption, right? Does not show any signs of eruption. So this is one of the category of volcanoes. So types of volcanoes, we have this active volcano, dormant volcano, and the extinct volcano. These are types of volcanoes, which is quite easy. Now, structures which are associated with the volcanic eruption. To explain this point of structure associated with the volcanic eruption, we have to add one more line to address this question. How do we associate it with it? By writing that the volcanic eruption is explosive as well as quiet, depending upon the silica content of the lava, whether it's acidic lava or basic lava. So how do we write this? So something like, based on the lava or silica content, right? It is acidic lava and basic lava, which are explosive and quiet, because the former has less fluidity and the later has higher fluidity, right? Higher fluidity. So now we have volcanic cones which are formed by volcanic eruptions, right? This acidic eruptions, volcanic cones formed by acidic lava, right? Volcanic cones formed by acidic lava. So you can give the examples of the cones such as cinder cone, right? Then there is a composite cone, composite cone and the parasitic cone. Whereas the basic lava leads to the formation of plateaus only. Basic lava, because it has a higher fluidity, so when it comes to the surface, it flows and forms thin sheets of lava. So as the sheet layer after layer after layer is accumulated, that forms a plateau shape or the table-like land called as a plateau. So basic lava leads to the formation of plateau itself. So write about this point that it leads to the formation of plateau, right? A table-like land, because there is a continuous formation, and that is also called as trap or trappen, because trap is a Swedish term for stairs or step-like formation. So because the fluidity is very high in basic lava, there is one layer, second layer, third layer, fourth layer, fifth layer. So layer after layer after layer gets deposited on the surface. This is how we can relate to this particular point. I know the number of words will get over. You will take so much of time to write this much. Now, towards the end, but we can't leave at the same time. Towards the end, we will write that there are some intrusive rocks also. Intrusive rocks as well. These intrusive rocks are because the magma accumulates in the deeper layers of the crust itself. This is how you can address this, because you can't write everything, because if you as you keep writing everything about it, about volcano and every dimension of it, surely you will be wasting, you will be using somewhere around 400-500 words, and you just have a word limit of 200 words. So just compress it, right? That there are some rocks which come to the surface and form the cone. Acidic lava generally form cones as it has lesser fluidity, and basic lava, which has a higher fluidity, accumulates in the form of thin sheets, giving it rise of a shape of a plateau, also referred as trappen or trap. So this is about intrusive and the lava which is, or the magma which is unable to reach to the surface, accumulates in the spaces present in the crust, called as intrusive rocks. Good enough. Now we can cite some examples, right? Examples, you can quote a lot of examples such as Mount Stromboli can be an example, Ojas del Salado is an example, and right, Ojas del Salado is an example, Mount Rainier is an example. So there are few examples that we can quote, and that is not an issue. But what should be the conclusion for this? How do we conclude this topic? Because we have written enough about volcanoes. The last conclusion aspect that we suggest to everyone should be something very applied, should be something like futuristic. When I say applied here, we can say that volcanoes, in the conclusion aspect, volcanoes also play an important role in finding internal composition of Earth. Internal composition of Earth. Right? So when I say internal composition of Earth, you can write that it is one of the source of information, right? One of the source of information, and that should be the last line for such topics. So whenever you talk about earthquake, volcano, towards the end you must write this point that they are very important sources of information, which is the natural source of information to find internal structure of Earth. Full stop, because you don't have a lot of words. Okay, now what other dimensions can be asked on volcano? We have discussed almost all the dimensions related to volcano and volcanism. There can be a question asked on distribution of volcanoes. Second, distribution of volcanoes. This is another dimension that you can think of or you can prepare for. When I say distribution, they can ask why volcanoes are related or located, if not related, but located along plate margins. Along plate margins. You can expect this question in exam. So if a question is asked that why are volcanoes located along the plate margins, you must understand that we have to mention about one line, that is they are associated, their number one dynamic, they reflect, or they are because of the dynamism of earth. Dynamism of earth is maximum along the plate margins, or the forces which are required for the formation of volcanoes are most intense along the divergent and convergent boundaries. So the most intense forces are located in these two margins. That is why they are located along the plate margins. And then you explain the process. Don't leave it there. You have to explain the process also, that how plate margins lead to the formation or development of such volcanic eruptions. Must write that part also. Other aspects can be asked related to the structures formed in volcanoes. Structures as in cones, intrusive rocks, and their significance. Intrusive rocks and their significance. For prelims examination, I am sure you must have read about the intrusive rocks and their significance, that it is a surface, right? And there are some volcanic accumulations under the surface, which is referred as batholith, called as laccolith, which is the umbrella shaped feature, laccolith. Then there is this anticline and syncline formation called as phacolith. There's horizontal accumulation called as sill. There's a vertical accumulation called as dikes. And you can expect this question, that the structures which are formed by the volcanic eruptions. So we have the extrusive structures forming cones and plateaus. I've just explained acidic lava and basic lava. Composition of lava determines the structure that we see on the surface of earth. And then we also may expect this question called as that intrusive rock formation. How intrusive rocks are formed? Yeah, other dimension we need to explain is about intrusive rocks. So when you end the structure of volcano, whether you are anything related to the volcanic eruption, the formations like structures or landforms formed by the volcanic eruptions, anything, please understand that if I take an example of this batholith here, this is the surface, these are different layers of the surface. You would write that volcanic eruptions which took place in the Precambrian times or in the very long geological history of earth would have got exposed by now. You can write something like the subaerial erosion, or simply you can write erosion exposes. Erosion is a removal of top layer of earth or lithosphere. So due to the removal of top layer of lithosphere, this erosion can expose. Suppose if I keep removing these surfaces, these layers, what is going to get exposed? The batholith is going to get exposed. Due to the continuous erosion of the surface, intrusive rocks get exposed. That is, or batholith, etc. can get exposed. These are called as patlands. P-A-T, patlands. Those patlands or batholiths, when they get exposed, they form a very important source of minerals. After all, volcano is a eruption of minerals. So eruption of all this exposes patlands, exposes batholith, which become the mineral or the storehouse of minerals, mineral heartlands. We can quote one example, that is Chota Nagpur region of India. Chota Nagpur is an example of such patland, and that is why it is called as a mineral heartland of India. This is also one of the dimensions that you can expect in your exam. right? So my suggestion is that you prepare volcano in detail. The question has been asked on fold mountains. I'm sure you know about fold mountain. And if you get a question on earthquake, fold mountain, volcanoes, you know, the basic process remains same, right? It is the same process. And to explain the same process, you mug up this definition that their lithosphere is divided into many fragments called as plates. These are sliding over asthenosphere due to its semi-molten nature, energized by convective currents generated deep inside the asthenosphere due to decay of radioactive elements. So memorize this, or at least remember these keywords. This will help you to answer 4 questions, at least the introduction for the 4 questions. One is plate tectonics, second is earthquake, third is volcano, fourth is mountain building, or anything related to fold and fault. Right? So let's move to the next discussion now, next dimension of geomorphology. Okay, now second question that we see here is weathering is a complex phenomena involving a number of processes and is influenced by various factors. Elaborate. Till now we did not focus on weathering. We haven't had any question on weathering. But you know, there are some unexpected questions also in exam. So we chose plate tectonics as one of the question, and related to the plate tectonics, like that would cover up mountain building and volcanoes and earthquakes. The second part is weathering and erosion. So we don't expect land questions on the landforms in your mains examination. Fluvial landforms, glacial landforms, karst landforms. We don't expect that much, but the process can be asked, and the chances of the process that stands a chance in mains is weathering, because it is also associated to the soil formation. Okay, let's try to understand the concepts of weathering that one should know. So one should know about the definition of weathering, which is quite simple. Right, definition, I don't think there should be any problem related to that, disintegration of rocks and so on. The question is, it is a complex phenomena. Why is it complex? Let's try to visualize. And influenced by various factors. So the next demand of the question is factors influencing weathering. Now, which are the factors which influence weathering? Right, we need to understand that and then elaborate and explain this process. So basically 2 things that question demands. Number 1 is the definition of the weathering. Number 2 is the factors which influence the process of weathering. So definition is very simple, that it is disintegration of rocks in situ. Right? Rocks in situ. Then we'll write the the introduction separately, right? As of now, just try to understand that disintegration of rock in situ is referred as a weathering process. Factors affecting. Number 1, it depends upon the nature of the rock. Nature of the rock. That is composition of rocks, the percolation of rocks, permeability of rocks, or porosity of rocks. So permeability, porosity, nature or the composition of rocks. Like for example, if rocks have higher iron content, they tend to get oxidized into ferric oxide. If it has aluminum content, then again it gets oxidized. If it is calcium carbonate, then there's process of carbonation. So these are things that we can collect right now in the mind, right? Then we also have some other conditions, like if rocks are having higher degree of porosity. Porosity means there are a lot of pores and percolation of water can take place through the cracks. So if the water can percolate through cracks, there are chances that weathering can be faster. If there's more permeability, water presence can also create that. So these things come to our mind. So when I say nature of the rocks, it is the composition of rocks. Number 2, the physical structure of the rocks, that is porosity and permeability. Permeability of rocks. So these are dimensions. Another factor which may not look like a factor that we just see so easily, and that is climatic condition. Climate is one of the most dominant factor leading to the weathering process, or that influences the process of weathering. So climate, let's try to understand a bit how climate and how these factors play an important role, and then we'll structure the question, this particular answer. Okay, so composition, first point is the nature of rock, that is related to the composition. So composition, if it is, as I said, if it is iron containing rocks, they tend to get more oxidized and lead to the formation of iron oxides, etc. Right? Iron oxides. And the process that is taking place here is the process of rusting. Now, if rocks contain, so we'll write the calcium carbonate containing rocks undergo the process of carbonation. Carbonation, like in karst landforms. If the calcium carbonate rocks is that is dominant. Similarly, like we have the chemical composition of rocks playing an important role in that determines weathering. There is one more important aspect that determines weathering. That is, if rocks have many crevices, that is many cracks, the percolation of water is easy. Percolation of water can happen and can exert pressure, right? Can exert pressure on the rocks. Exert pressure on the rocks. This is how nature can play an important role. Like we have a lot of cracks in the high mountainous regions, or regions which are at a high altitudes or cold climatic conditions. Now, the other factor that I have mentioned is climate, and now pay attention. Nature is quite simple to understand. Climate. Now, so far as the climatic condition is concerned, there are two broad climatic conditions that all of us can understand. Either the temperature is very high or the temperature is very low. Either the rainfall is very high or the rainfall is very low, right? That is the climatic condition that we consider. So it is temperature and rainfall that we consider. Temperature and rainfall. So far as the temperature and rainfall is concerned, in the regions where temperature is very high and rainfall is low, let's see that part. And you must have read about the examples of weathering. So we'll write in the regions where climatic conditions with very high temperature and low rainfall. Can we call it as hot deserts, right? Hot deserts. Now here what happens is rocks, the temperature of the rocks increases during the daytime. So there's an expansion in the rocks, right? There's an expansion in the rocks during the daytime. And since the range is very high, during the night time the rocks contract. So expansion and contraction of the rocks leads to the disintegration of outer layer or breakdown of outer layer. We call this process as exfoliation. We call this process as exfoliation. So in the regions where we have high temperature, low rainfall, most common process of weathering is exfoliation. That is breakdown of rocks due to alternate expansion and contraction of rocks. That is due to temperature changes so much. Now what about low temperature and low rainfall? low temperature and low rainfall. That is, we are discussing the cold deserts. Low temperature, low rainfall, cold desert, extreme cold climatic conditions. Now, in this scenario, the water percolates in these rock structures. Water percolates in these cracks. Like we have just taken an example over here that if there are cracks in crevices. So just if I draw the diagram here, these are supposed cracks present in the rocks, and if water gets accumulated here, we know that if it freezes and gets converted into ice, there's an expansion in ice. Expansion in ice. Ice expands. Water, when freezes, expands. And due to that expansion, it exerts huge amount of pressure in the rocks. Huge amount of pressure, and ultimately rocks break down. So why is this breaking down? Why is this disintegration taking place? Is because of pressure exerted due to the presence of ice or presence of water. Water is very low here, but it can't be absent. In the regions where the temperature is very low and it goes below freezing point, it expands and develops a crack. It's like if you fill a water bottle completely and keep it for freezing, after some time when it freezes, it may break the bottle itself because there's an expansion. And due to that expansion, some fragments will be separated from the rocks. Now, this process is referred as the freeze and thaw action. Freeze and thaw action. So, in the regions with cold desert or cold climatic condition, what is the process of erosion? Freeze and thaw. So, we had discussed with the low rainfall condition, right, in the drier areas, cold deserts and hot deserts. So, we can say that in these regions, physical weathering is most prominent, right? I'm repeating, the structuring of this answer will be done separately, like we'll structure the answer separately. Let's try to first understand what we are supposed to discuss here. Okay. Then let's see, now we'll consider regions of high temperature, like tropical conditions, and high rainfall. High temperature and high rainfall. That is moist tropical regions, primarily moist tropical regions. The moisture content is very high. There is huge amount of moisture present in atmosphere, right? So water vapors are abundant, right? Water vapors are abundant. The abundant water vapor condition, sometimes with carbon dioxide, because carbon dioxide is also present in atmosphere, carbon dioxide forms this acid called as carbonic acid. It's a weaker acid, but then constantly being formed in the atmosphere. This carbonic acid can react to calcium carbonate and can corrode, can cause corrosion and result in the formation of bicarbonates. And this process is what is called as carbonation. So in the regions where rainfall is higher, moisture content is more, and the temperature is relatively higher, like tropical conditions. So in a tropical conditions with less moisture, with a higher moisture, there can be the process of carbonation, what happens in the most of the regions of like tropical and equatorial conditions. Then we have another aspect, same, if the moisture condition is abundant, there's huge amount of water. Now iron reacts with it and can form these hydroxides. This hydroxides reacts to the oxygen and can get oxidized, right? Oxidized This process is called as rusting or simply oxidation. Now, we cannot write all the examples. We have to write few examples to explain the factors. Now, the moisture present in the atmosphere is also leading to the process of chemical weathering. So, we can say that in moist climatic conditions, there is more of chemical weathering. And in physical or in the regions where temperature is very high or extreme climatic condition, whether it's a low temperature or high temperature like hot desert or cold desert, we have more of physical weathering conditions. So this is how the process goes on. Now let's structure the answer. Let's structure this answer. The question demands that physical weathering, right? Sorry, the process of weathering and factors which are dependent upon it, or on which it depends rather. So obviously we'll write that the conditions on the surface of Earth causes or results in breakdown and accumulation or formation of rocks. Weathering defined as, how do we define weathering? Disintegration in situ is one such process, which is determined by following factors. First factor is the nature of rock. Go on explaining nature of rocks. Give some examples. You can't give explanation for all of them, right? Explain the nature of the rocks like permeability, crevices, porosity, or for that matter the composition of the rocks. Then second, climatic condition, nature of rocks and climatic conditions. Climatic conditions may, you can talk about two conditions. One is extreme dryness with low temperature, and with high temperature you can write simply cold deserts or hot deserts, and regions with moist conditions. Here in moist conditions, chemical weathering is more prominent. In drier conditions or extreme climatic conditions, physical weathering is more frequent process. And now you can also see, just for the understanding sake, whether we write in the answer or not, but then just for the understanding, we can understand this point that in this entire process of weathering and everything, in moist conditions, in the regions where the temperature is like high and moisture conditions prevail, we have this colored conditions, like colored soil, like red soil, yellowish soil, or this lateritic getting red and yellow soil. So why is its color? Because there's oxidation, there's hydroxation, there is carbonation. So that imparts different colors to the soil. And in the regions where we have extreme climatic condition like dryness, we have coarser particle nature of the soil. This is all associated with the weathering. And last, the significance of weathering. In last point, we are going to write significance of weathering. What is the significance of weathering? It plays the most significant role in fact, the first step of soil formation. It is the initiation, it is the initial process of pedogenesis. It is the process of weathering that initiates the pedogenesis or soil formation. This is about weathering and expected questions. Now, what else can we expect from weathering? We also expect that in weathering, you may get a question from weathering and soil formation, something related to it. So you should have a clear definition of soil and mention that weathering is an associated process, in fact the first process of soil formation. You may also get a question something like climatic conditions determine, or climatic zones determine the process of weathering, something like that. How weathering differs in different climatic zones. So that part should also be clear, right? We are generally less prepared for such topics. Okay. So we'll see one more question. Now it also completes the weathering past aspect, then the plate tectonics aspect. Then we'll take one more question from geomorphology and then we'll switch over to next aspect. So that will complete the discussion on geomorphology. So the third question from the geomorphology that we have known, and I'm sure you know about this question: discuss the internal structure of Earth and comment on S and P wave shadow zones with suitable diagrams. Discuss internal structure of Earth, right? So this is the initial point of the geomorphology. So if we handle this question, so that would complete our internal structure. Then we'll come to plate tectonics. Almost we can understand different dimensions, and then lastly weathering and associated whatever process is associated with it. So internal structure of Earth, and there is this very beautiful line that is mentioned in some books, and I really think about this line again and again. I'm forwarding the same line to you. You can read it and maybe use it in your answers, and that summarizes a lot of things. What is it? It says mapping moon is easier than finding what lies beneath our feet. Mapping moon is easier than finding what lies beneath our feet. This is, we can probably start with this. Maybe not the same line, but the same idea that the internal structure of Earth is still a mystery. Geographers have worked hard to find out the internal structure of Earth, something of that sort. If it is not a complete mystery, but yes, we do not have also the complete information about it. So what we have, what is actually the trend, that negative words should be avoided in your answers. No, not, never. These negative words, please avoid as much as you can. Right? You need not to write much about it. Anyways, but you can always say that it's the nature of the Earth, difficult nature of Earth makes it quite difficult to find out to study details of Earth in, right? Now the question is, why is it so difficult? Mapping moon is easier than finding what lies beneath our feet. What are we supposed to know to answer this question? First is, why is it difficult? Why is it difficult? Right? That is the first question. That is first we need to write. That's because of immense temperature and pressure. Immense temperature and pressure that lies below the surface of Earth. Now, what is the source of temperature? It will be excellent if you can mention the source of temperature or heat, and also mention why pressure is high. So basically you have to mention why temperature is high and why pressure is high. Basically that part. So why is it difficult to find internal structure of Earth? Temperature, So temperature is high due to the primordial heat. Primordial heat of earth. What is primordial? At the time of birth, primary heat. So primordial heat of earth is present, it is insulated due to solidification of rocks. Just write that, enough. The heat that was present with the surface of earth at the time of its formation got trapped, got insulated. Why? Because there was solidification of crust. Earth's crust got solidified, and rocks are poor conductors of heat, do not allow heat to go out. So you just add one line, that is insulation of earth, insulation caused by the solidification of rocks. That is why the heat is high. And we'll write something that superincumbent load, that is of sediments keep increasing pressure and keep increasing density, right? So density is high due to the superincumbent load, or the pressure is high because of the superincumbent load that keeps on increasing with the depth. So here we have this one word, right? So what we are trying to do here is we are just trying to justify the reason why mapping moon is easier than finding what lies beneath our feet. Structuring of the answer, I'll do it, we will discuss it a little later. So this is how we know about it. Now, when you write something like that in your answers, that automatically makes this S waves and P waves quite useful. Conceptually, we cannot reach to the directly to the internal part of earth, but they're quite similar to the, or analogous to the X-rays for human bodies. If you've seen an X-ray film, what happens is when X-rays pass through a human body, what do we see on the X-ray film? Is not actually any image or photograph. We actually see the shadow. X-rays can pass through the softer tissues, the muscles, etc., but cannot pass through hard tissues like bones and cartilages. So if S waves are unable to pass through the bones and cartilages, that means they are going to create a shadow zone. What is a shadow zone? A zone through which rays cannot or light cannot pass, right? So similarly, when X-rays are unable to pass through the human body, they create this shadow zone on the X-ray film. So something like, you should be able to understand what is that shadow zone. So if we are unable to trace P waves and S waves at the opposite end, or they create a shadow, because shadow is the zone where waves or rays are unable to reach, they cannot pass through that, they are unable to pass. So if they are unable to pass through a particular layer, we can trace and find out why is it so. For that, we should be clear with the properties of P waves and S waves. So we must understand that these P and S waves, which are also called as primary waves and secondary waves, right? These are released by the process of earthquakes. During earthquakes, they are released at a point called as focus. So P waves being longitudinal, very analog, similar to sound waves, right, which can travel through solids but as well as through liquids. Secondary waves, which are analogous to the transverse waves, cannot pass through liquids, can pass only through solids, right, can pass only through solids and not through liquids, right. So if we analyze the movement of P and S waves, we can analyze the movement of entire condition, right. We can analyze the internal structure, because here it can pass through solid and liquid, and this cannot pass through solid and liquid, it can pass only through the solids. Now all that we have to understand, the presence of regions where P waves are actually recorded. And regions where they are not recorded will be called as shadow zones, because the question defines, like, demands an explanation on the shadow zone. So we talk about shadow zone is a region where P waves are unable to pass, we call that as P shadow zone, and where S waves are unable to reach, we call that as S shadow zone. So you must have seen this diagram in your NCRTs, in your materials, etc., that there is this one point called as focus, or we call it as a hypocenter. From there you will show these waves reaching to the other end, recognized by the seismometers, right? These P waves, S waves, P waves, S waves, all these regions P and S waves. So, but after a while the P wave gets diverted, P waves get diverted. So here we have this zone called as P shadow zone. P shadow zone, right? That is what the diagram says. Some books you may find 103, some books it is 105 to 145. So I'll go by NCRTs, what they say, 105 to 145. In this zone there is deviation of P waves, and that is what is referred as P shadow zone. Opposite end, yes, we record P waves, right, but we do not record any S waves to the opposite end. So if you draw this diagram, show that there is a shadow zones, there are regions where there is no P wave, or the regions where there is no S wave, right? And that can happen only if there is change in medium. That can happen only through if there is change in medium. The change in medium is not possible, like we can't have gases there, but yes, right, there can't be gases there, but we can have these due to high pressure, liquid is there and solid. So we conclude based on this that there is a, based on the deviation of P wave, that there is a liquid layer inside the surface of Earth, and that liquid layer was called as core, right? That was called as core, and later it was found that P waves move faster. P waves get faster in deeper layers of Earth. In deeper layers of Earth. Since it gets faster in deeper layers of Earth, it cannot be possible without a solid core. It was concluded then inner core is solid. Solid, because waves can get faster through the denser medium or solid medium. Waves are like sound waves, travel with a higher velocity in the solid medium, and they travel with a lesser velocity in the liquid medium. So that is what we need to mention here about the inner core getting faster and all that. And also the behavior of some more waves were discovered, based on which we have classified Earth in following layers. So now comes the layer of Earth. Now comes a layer of Earth, which is different layers of Earth, and you can draw this diagram showing that there is, this is the crust, right? This is the mantle divided as upper mantle, this is the lower mantle, core called as outer core, and inner core, which is a solid state. So outer core is in the liquid state, right? Liquid state, inner core being in the solid state, and but composition is largely nickel and iron, whereas mantle, the composition is slightly silica magnesium, crust it is mainly silica aluminium. That is structure, and here thickness if you want to write, this is 30 kilometers, upper mantle up to 700 kilometers, inner mantle up to, lower mantle up to 2900 kilometers, outer core up to 165 kilometers, and the inner core up to 6371 kilometers. But you don't have to write so much of detail. If you remember it, okay. If you do not remember it, it's perfectly all right. You should not miss upon the nature of these layers, like which is solid and which is liquid, and the composition of this. And we'll also mention that the outer part of upper mantle, right, the outer part of upper mantle, there is a semi-molten layer due to the presence of radioactivity, which is referred as the asthenosphere. This asthenosphere is has been formed due to the presence of radioactive elements, right, due to radioactive elements which make it semi-molten. Now, this is the information for internal structure of Earth. What type of questions are expected? Yes, the question can be asked, what are seismic waves and how do they play an important role in the finding internal structure of Earth? The question can be asked that internal structure of Earth is difficult to find. What are the different sources of the information? So, one of the major source of information, let's now structure the answer. Let's go back to the question. Question is, discuss internal structure of Earth and comment on S and P wave shadow zone with suitable diagrams. So, we have drawn the suitable diagrams. This is the suitable diagram, and another diagram if we have to draw is the internal structure of Earth. So, after having mentioned about this line that mapping moon is easier finding what lies beneath our feet, the next line can be, it is because of higher temperature, or we may change this entire introduction itself. How do we write all this with the minimum words? We can also say something, the primordial heat or intense primordial heat trapped due to insulation caused by rocks, caused by the solidification of rocks, trapped by the solidification of rocks, and the caused by solidification of rocks, and the superincumbent load, exerting intense pressure in deeper layers, makes it difficult or impossible to study Earth by direct observation. So that's what we have tried to do here. We have given the entire reason why is it difficult to find internal structure of Earth, and now direct observation is difficult. Now when you write this, now we come to write next point. There are natural processes such as earthquakes, which help to get deeper insight about internal layers of Earth, right? Deeper insights about internal layers of Earth, as seismic waves generated by the process have a deeper reach. A deeper reach. Now, when you write seismic waves generated by the process have a deeper reach, now the answer becomes easy. We'll write in the next point. Then we'll write in the next point that there are two types of seismic waves, P and S waves. They can travel longitudinal waves, or we can also write their body waves. In fact, other waves is called as a surface wave that is responsible for causing earthquakes. So we'll focus on this, that from the focus they travel in different directions, and when we observe these P and S waves, P waves form a shadow zone between 105 to 145 from the focus, as they cannot travel through the liquid medium, they deviate in the liquid medium, although they can pass, they form a shadow zone, which shows that there must be a liquid layer deep inside the earth, which was called as core. But as they accelerate in the deeper layers, it was concluded that faster movement of P waves could be explained only if there is a presence of inner core. Full stop. Conclusion for this topic. What is the conclusion? You can write, when you can draw this diagram, in the conclusion itself, you must focus that the dynamism of Earth's surface is due to its internal structure, right? Due to its internal structure. So to understand, a deeper insight or further study is required to understand these phenomena which may help us to predict phenomena like earthquakes and tsunamis. Full stop. So we are going to the application part, right? We are trying to understand not only the internal structure of Earth, but also going one step further and mentioning that we can, what is required in the future, that we must study it in detail, and as we study in detail, we must also be able to predict earthquake, right, in the near future. This is how geomorphology. So my suggestion is that prepare these three broad dimensions: internal structure of Earth, plate tectonics and continental drift in detail, and little bit about weathering. That should be it for geomorphology. Okay, let's go to the next point. Next question now. So this brings us to another question, that is, what do you understand by frontogenesis? Right? This is a question on climatology. Weather phenomena associated with the cold and warm fronts are different in nature and intensity. Illustrate. Okay, now reason to take this question. See, what are the different topics that we can expect in climatology? Structure of atmosphere, most unlikely. Temperature, yes, there have been questions on temperature. Already a temperature inversion has been asked. So whether, I mean, the chances of repetition is very low. Then we had a question on air masses. I think 17 or 18 means there was a question on what are air masses and their role in macroclimatic condition. And if you have studied geography, I'm sure you would have studied, surely. After air masses, there is this topic called as frontogenesis, which are like associated. It's like when you study air masses, automatically you will reach to the frontogenesis. Or you can also say that without understanding air masses, we cannot understand or write anything about frontogenesis. So if the air masses question has been asked on air masses, the question on frontogenesis is very much expected. we expect question on fronts because it's a continuation of air masses. And broadly, UPSC has touched almost all topics of climate, except for fronts. Like they have asked questions on cyclones, they have question on temperature. Winds have not been asked so detailed, but the questions on air masses has been asked. So now we expect a question on fronts and frontogenesis. So let's handle this question. One thing good about climatology is that, you know, in this entire physical geography, but especially in climatology, is that either you know the concept or you do not know the concept. That means the best part is that if you understand the concept, if you know the concept, you can write the answer. But if you do not know the concept, you really cannot write anything in it. It's not like once upon a time and you write something in your answers. No, you have to be very particular, very peculiar about your answers, and because 200 words writing everything, you can't go here and there. And straightforward questions, straightforward answers are required. So a lot of people ask us, like, geography, is it scoring, is it not scoring, etc. But I tell them, if you get questions on physical geography and you are good with the concepts, you have a good understanding of concept, it should be giving you good scores. It should be scoring. Many a times what happens is we don't write or we don't have a good clarity on concepts, and that is what creates problems in exam, right? Anyways, let's try to understand the concept as what is frontogenesis and other aspects. Okay. First is the definition of frontogenesis. And then we'll talk about this cold front and warm front. So the process is quite simple. The definition is quite simple. The process of formation of front, is called as frontogenesis, right? It's called as frontogenesis. Now the question is, what is front? Then we have to define the next. There are two dimensions, two definitions in the same explanation, the same frontogenesis. First is process of formation of front, right? This is one point. Second is, next point is the transition zone. Next point we can write is the transition zone between two contrasting air masses. Two contrasting air masses is called as front. The transition zone or the boundary between two contrasting air masses is called as front. Now, that is, sometimes you get this question where it is incomplete without two definitions. So first, yes, frontogenesis we have mentioned. We need to go one step further and explain what is a front, and it's easy. Okay. Coming to the next point of this topic, of this discussion, we'll add one more line, and that is quite important here. We'll add one more line, is the along air convergence zone, right? Such, or simply convergence zone, fronts are formed. So the fronts are mainly formed in the zone of convergence. Like in the subpolar regions, there's a convergence, right? There's a warm air mass, cold air mass converging, and that is how fronts are formed. So definition is, this much is good enough. In the zone of convergence, we have the formation of fronts. Yes, in equatorial areas also there is a possibility of frontal formation, because there are two winds which converge, which is called as intertropical convergence zone. right? Warm air mass and cold air mass converging at equatorial areas. But fronts are most unlikely to be formed there. The reason why, because both come from the tropical areas, there is no contrast in the temperature. There needs to be a contrast in the temperature, right? So if you see this ITC-Z at equator, there's northeast and southeast trade winds converging at this point. So this is the front, could be a frontal zone. In fact, we also call it as intertropical frontal zone at equator, but not formed at equator. Do both of them come from 30° north and another comes from 30° south, so they'll be carrying almost the similar temperature air masses, right? But if you see the 60° belt here, one comes from the 30° region, like subtropical high pressure belt, another wind comes from the polar high pressure belt. So this winds carry warm air masses, very warm air masses, and this wind polar easterly carry very cold air masses. The convergence happens at 60°, and that leads to the formation of fronts at 60° zone. So that's why we have more pronounced frontal formation, more frequent frontal formation at subpolar latitudes, right? This is one aspect we must understand. The second question, second part of the question is a bit demanding. It says weather phenomena associated with cold front, warm fronts, and different nature and intensity of this. So what is the weather phenomenon associated with the fronts? First, we need to define the fronts. So the question demands that you write about different types of fronts, and suppose cold front. To understand weather, we must write one line definition of cold front. So cold front is formed when cold air masses or air mass moves faster than warm air mass. Cold front is formed when cold air mass is formed faster than warm air mass. Now, I must tell you one thing, that a lot of people have confusion related to this. A lot of questions are asked to us related to this cold front moving faster. The question is quite genuine, and the doubt is also quite understandable, that cold air masses are denser, so they should be very close to the ground, and if they are closer to the ground, they are subjected to undergo a lot of frictional drag and the speed should reduce, right? But what happens here, understand one point, that air masses do not move on their own. If you have such a question, just to address that, air masses do not move on their own. Air masses are actually dragged by winds. So a wind carrying a cold air mass can be faster. How? Maybe it is passing over a surface which is having lesser friction. Like if it passes from the water bodies, there is no vegetation, no friction at all, the wind speed is higher. Maybe it is passing over a region which is a desert area, or where vegetation cover is very less. So the speed of the wind is dependent or determined by two larger factors. One is the pressure gradient, second is the frictional force. So maybe the pressure gradient is higher, it comes from a very intense high pressure region. It comes from regions where frictional drag is very low, the speed of the wind can be higher. So if the speed of the wind is higher, obviously the air mass that is carried by that particular wind can also be higher or lesser, irrespective of the density of such air mass, whether it's a warm air mass or a cold air mass. Might get it clear. So this is cold air mass moves faster than the warm air mass. Now the second point, now coming to the weather, to explain weather phenomena, we have to go in one more detail. Detail is that cold front, or along the front, simply you can write, along the front, cold goes or enters the territory of warm air mass. territory of warm air mass. When we say territory of warm air mass, we mean the zone of the air mass. And cold, because it is denser, it goes underneath it. And mechanically uplifts the air mass. Mechanically uplifts the warm air mass. So cold goes underneath the warm air mass and mechanically pushes it upwards. So as the warm air mass rises, what is going to happen is the rainfall. So you can write weather associated with it is the pressure decreases. Atmospheric pressure decreases because after all the warm air mass is rising, plus relative humidity increases more than 100%. So as the air mass becomes supersaturated, it causes torrential rain. Torrential rain means extremely heavy rainfall. Torrential rain means very heavy rainfall. Right? Very heavy rainfall. In a very small area, intensity of rainfall is very high. So this is the pressure decreases, relative humidity is very high, supersaturated, causes torrential rain. That is the weather associated with the cold front. So you need to draw the diagram also. This is the warm front. This is the cold air. Cold air. Right, and then can cause rainfall here. And this you can write that it can vary from 1:30 to 1:100. The slope of this boundary can vary from 1:30 to 1:100. This is vertical to horizontal ratio. Well, you don't have to mention it's a vertical to horizontal ratio. You just have to mention 1:30 to 1:100 is the slope. It is understood that it's vertical to horizontal ratio. So that is what forms the intense or very dark and dense clouds causing torrential rainfall. Cold front. Then warm front, little different than what we see here. Warm front. So let's define warm front. Warm front is the condition when warm air mass moves faster than cold air mass. Warm air mass move faster than the cold air mass. That is how we define warm front. So in this case, the condition is quite different here. It is not something like what we see in the cold front. Now, again, the condition can be same. An air mass that is carrying a wind that is carrying a warm air mass can be faster. So warm air mass can be faster. So a lot of people do not have a confusion here or a problem here because they believe that warm air mass must be lighter. It's above the surface and can grow faster. True, yes, that is the case, but still, warm air mass is actually moved by the wind that is carrying it. Okay. Now what happens in this case? Cold air will not be above the ground, it will be attached to the ground itself. After all, it is denser. So since it's denser, it remains attached to the surface. Moreover, this cold air. Moreover, the warm air cannot go underneath the cold air, right? Because it's lighter. So at the point of the contact, what happens? The cold air, warm air mass rises. So as it rises, there will be this boundary zone formed. So in this case, there will be more like thermodynamic modification. Previously, it was the mechanical modification. There was cold air was pushing the warm air mass to rise. Well, in this case, it's different. In this case, warm air mass . thermodynamically rises up. Thermodynamically rises up and forms, obviously the slope will be very gentle, right? Forms a gentle slope of the boundary. Boundary is the boundary between two contrasting air masses, that is front. Forms a gentle slope of the boundary, right? And this gentle slope of the boundary leads to the moderate rainfall. Again, the low pressure will decrease after all because air mass is rising, and a very moderate rainfall. Moderate rainfall is caused. So you can draw the diagram showing a very gentle slope, warm air mass. In both cases, the warm air mass is rising, the cold air mass is near to the surface, right? And there will be moderate rainfall taking place here. The ratio is 1:100 to 1:400. That is, if we go horizontally by 100 kilometers, the vertical movement is just 1 kilometer. So that in the previous case, if we go by 30 kilometers in the horizontal way, we will be rising by 1 kilometer, right? So that is the vertical to horizontal ratio. That's about weather associated with the warm front and the cold front. Well, I guess easy if your concepts are clear, just as, right? And different in nature, in intensity. So which region has a higher intensity rainfall? Cold front. Why cold front? Is because the cold front has a torrential rain, the ratio is much higher. Then there is also this warm air masses, warm fronts where the ratio, elevation is not that high. It's a very moderate kind of condition. Rainfall is very moderate rainfall, a drizzle at times, right? So this is about air masses. There can't be many dimensions, to be very honest, can't be many dimensions. So what would be the conclusion for this? In the conclusion we can write with just one line that sometimes the frontogenesis or frontal formation is associated with intense low pressure, that forms temperate cyclones. Formation of temperate cyclones, full stop. Because temperate cyclone is frontal in origin, so sometimes the convergence can be so intense that it can lead to the formation of temperate cyclones. And what is a temperate cyclone? When the warm air mass rises, there is circulation of winds over here because of the low pressure zone. So it can be detailed. Temperate cyclones in general studies, well, if you know the frontal formation, frontogenesis, you know the basic idea about temperate cyclones. That shouldn't be a problem. Never a problem, in fact. So that way you can work through this. Okay, let's go to the next question now. But that doesn't mean you don't prepare for air masses. Please prepare for the air masses also. Just go through the air masses. Maybe an outside chance that question can be asked on air masses. That brings us to the next question, and then I'll come to the global climate system. Explain how local winds and different form of planetary winds, giving examples, highlight the role of local winds influencing climate, agriculture, livelihood in various regions. Now, the question demands some detailing and detailed understanding about local winds. Planetary winds is easy, right? It's very easy to explain planetary winds. Planetary winds would be like, these trade winds, westerlies, easterlies. and nothing much to discuss about it, nothing much to worry about it. We can explain these. If you are clear with the pressure belts, you can be clear with the planetary winds also. Local wind is an issue for general studies. A lot of people in general studies do not emphasize on the local winds. Trade winds, westerlies, easterlies study in detail, then seasonal winds also study, monsoon and all that, it is clear, but local winds is one thing that we need to emphasize. So let's see what all can we write in such question. So first we need to define the wind, which I guess is easy, very easy to define wind. It can be defined as a horizontal expression of air circulation, right? Horizontal expression of air circulation caused by or formed by pressure gradient force, right? Pressure gradient force. So this is the simple definition of a wind. Why is it important to understand, take the definition of the wind? Is because we are actually explaining planetary winds and local winds. There are two types of winds. So here we'll write pressure gradient force, right? There are two types of winds. One is, three in fact: planetary winds, local winds, and the seasonal winds. So we need to define planetary winds, right? Let's define the planetary winds. So winds which persist throughout the year, they're called as planetary winds. Winds which are up to a local region called as local winds. Winds which change their direction seasonally called as seasonal winds. But how are we going to put these in words? So after having defined wind, what is a wind and how pressure gradient force is responsible for wind, you can write that the difference in, or simply pressure belts are also, or pressure gradients, pressure belts or pressure gradients formed across the globe due to rotation of earth and temperature variation right? You can also write in different way that the temperature variation, you can also write that the temperature variation and the rotation of earth have given rise to different pressure conditions or different atmospheric pressure at various latitudes, which form a gradient or which develop a pressure difference triggering the air movement. So you can continue from here and you can write this triggers or this causes the wind movement or air movement, rather not wind movement, air movement from high pressure to low pressure, from high pressure to low pressure. So winds which persist, now again, winds which persist throughout the year are called as planetary winds, also called as permanent winds. Like, take example, trade winds, westerlies, easterlies, these have almost the permanent nature. Full stop. Done. They don't ask much about the planetary winds. The question is mainly about the local winds, how local winds play an important role in livelihood and all these things. Now, when you talk about this, let's pick one more thread and move to the next aspect. Here we are going to write that local conditions produce air movement having the peculiar character which has a pronounced influence on local climate and thus carry a local name. Called as local winds. Thus carry a local name, and that's why they're called as local winds. So something about local winds we must define here, because showing that it is regional, showing that it has got a particular character, and that character is quite similar or quite peculiar to that region, influencing the climatic condition of that particular region and all that. From here we need to understand examples, because the question demands something detailed. What is the question demanding? Question says that highlight the role of local winds. We have defined planetary winds, we have defined local winds, right? So planetary winds show their presence globally, because question is about the different from the planetary winds. So planetary winds show their presence locally, globally, between the latitudes they are formed, whereas the local winds are formed due to localized conditions. So that definition actually differs. So here we talk about pressure gradients. Planetary winds are of permanent nature. Here we talk about local winds showing some local or peculiar characteristics. So that is how the two winds are different. Now we have to give examples. So you should be clear about how do they influence the local climate, and you cannot answer this question unless you take few examples of the local winds. How do they affect the livelihood of a region, agriculture or livelihood of a region? For that we need to take examples. So you can write they have in the definition itself we have written that they have a pronounced effect on the local climate and therefore carry a local name, whereas planetary winds do not carry any local name. Right? There's a standard name like westerlies, easterlies, etc. They are named by the direction they come from, and local winds are named by the name that they show the influence on. Okay, so here we start. The first local wind is Chinook. Very little about we'll write. Chinook basically is a warm wind. There's a very detailed phenomena of Chinook that one can explain, but depending upon the word limit, right? Word limit should not be breached too much. So this is a warm wind that blows in prairie regions of North America. Prairie region is this Canada and North American region, USA region. We know that eastern slope of Rocky Mountains. Prairie regions, right, which is along eastern slope of Rocky Mountains, right. Now, since it's a warm wind, it helps in the melting of ice melting of ice. And the melting of ice clears the ground, and that's why it is also called a snow eater, and that is why it carries a name Chinook, which means snow eater, as it helps in the melting of ice, the warm wind. And this melting of ice clears the ground for agriculture. How do we know that? How is agriculture being practiced in USA or Canada? They grow the spring wheat in the month of March and April. And also they are in the temperate zone, especially the prairie regions in Canada, they are in the temperate and subpolar regions. And the temperature remains below freezing point in these areas, and the ground remains covered with frost or it remains covered with ice. And manually it is not possible to lift that ice. So this warm wind that blows plays a significant role, and that clears the ground, clears the surface. Ground means the surface, and agriculture can be practiced over it. So wheat cultivation can be practiced over it. Right? There is a mechanism of heating of this phenomena. Like there's a mechanism, like suppose this is the Rocky Mountain, and on one side, western side, this air masses rise at SALR, that is saturated adiabatic lapse rate, because the latent heat of condensation is released. Right, and this particular air mass descends from the other side, right, and it becomes warm. The question is that we know that SALR, saturated adiabatic lapse rate, is just around 4 to 6 degrees Celsius per kilometer. It is much lesser than the normal lapse rate, which is 6.5 degrees Celsius per kilometer. Here it is 4.6. That happens because moisture present in the water, in the air masses, the vapors contain the latent heat of vaporization, but when they condense, they give away this heat. Due to the condensation, the latent heat of evaporation is released, and due to the release of latent heat of evaporation, it gets converted into water droplets, but heating the surrounding area. The surrounding region gets heated up, and temperature escalates, temperature increases. And due to this slight increase in temperature, the lapse rate is not 6.5, lapse rate is 4 to 6. The temperature does not decrease at the same rate. The latent heat of condensation that gets released is like, if the temperature here is 10 degrees Celsius at the surface, after 1 kilometer, the temperature is going to be like 5 or 6 degrees Celsius. Why? Because the temperature does not decrease at 6.5. The expected is 3.5. What exactly it is, this is expected as per the normal lapse rate, but that is 5 degrees Celsius. When it descends at dry adiabatic lapse rate. The temperature increases 10 degrees Celsius per kilometer. And it is 10 degrees Celsius per kilometer. Where is this additional heat that we get? So when it descends, come back to the surface, the temperature will be like 15 degrees Celsius. So on western side of Rocky Mountains near the base, it was 10 degrees Celsius. When it descends on the eastern side, the temperature is 15 degrees Celsius. That's because imagine an air balloon subsiding, right, in the atmosphere. So as it is subsiding, there is huge amount of pressure that is exerted on the balloon, right? Intense pressure is also exerted there, and due to that intense pressure, air particles in the balloon will start moving faster, right? If you keep compressing it, the air particles will also start moving faster. The faster movement of air particles will produce friction, and that friction produces heat. So that additional heat is generated by the friction produced by subsiding air, friction produced within the subsiding air masses, and that's called as dry adiabatic lapse rate, right? So here there's a air mass compressed, all the air particles will move faster and all that. That is why Chinook or the air masses along the eastern side of the Rocky Mountains become very warm, and that warm wind is warm air movement is called as Chinook, snow eater. Right? We have so many examples of Chinook. Now, after you have written a little bit about Chinook, you must also mention few other examples, like there is a name called as fawn. Fawn, it's a warm wind in Alps region of Europe. In Alps region of Europe, fawn. Second, another example, we can take example of livelihood now. Now we have taken example of agriculture. Let's take an example of livelihood, of course agriculture, plus general life, right? General life, when I say general life, that other than agriculture or other than economic activities, how do they play an important role? There is one wind named as Harmattan, a wind named Harmattan. It's called as doctor winds, called as doctor wind. Doctor winds. So, Africa, let's take an example here, Africa. It blows in the western Africa near Gulf of Guinea. Gulf of Guinea. Gulf of Guinea is this region over here, Gulf region. It is very moist. The moisture is very high, or you can say humidity is very, very high. So you would see that humidity sometimes is so high that it becomes very difficult to breathe, even like the conditions become so intense. Also, the moisture is the reason for the growth of germs and mosquitoes and etc. Life becomes very difficult. Then these winds blow over over Gulf of Guinea. That is the movement of these winds. And such winds carry dust particles from Sahara, because they pass over Sahara. And dust is hygroscopic. What is hygroscopic? The one that attracts moisture. That's called as hygroscopic. So when these winds pass over Gulf of Guinea, they attract moisture. Therefore reduces humidity. Reduces humidity. So if the humidity is reduced, moisture is reduced, the conditions get normalized, the conditions get relaxed. That is how Gulf of Guinea gets a relief from the high humidity conditions from Harmattan. So one example where it affects the life of locals. Besides this, it also has the detrimental effect. So this we have taken about Chinook and fawn, which fawn helps in the viticulture. Viticulture is the culture of cultivation of grapes in Mediterranean region. But so in answers we'll write that it also helps in this also helps in some winds also have some detrimental effect. Detrimental effect. What is or negative effects like Sirocco. Sirocco. It brings blood rains. It brings blood rains in Mediterranean region. What do we mean by blood rains? The red sand particles gets mixed with rain droplet, right? From the northern Sahara they blow towards Mediterranean region. So there's red sand particle. So when red sand particles get mixed with it, so when raindrop comes, it is reddish in appearance, right? But that raindrop particle which contains sand, can pierce through our leaf, can damage the standing crops. So it damages crops. So on one side, local winds have a positive effect on agriculture. Local winds also have a negative influence on agriculture. They have a positive effect on life. For example, Harmattan, relaxing, that is why they're called as doctor winds. At the same time, some local winds can also bring thunderstorms like Karl Veshak and nor'westers in New Zealand. Right, so Karl Veshak in India, which brings thunderstorms, and also we have in northeastern and eastern part of India, and another such wind is nor'westers, which bring thunderstorms in New Zealand. So therefore, these local winds have a very long effect on the life of agriculture and overall life for this. So they play an important role in climate, like they reduce the humidity. Example is Harmattan. They play an important role in agriculture, positive effect in agriculture. Example is Fawn and example is Chinook. They also have the negative influence on the agriculture, like Sirocco, damaging the crops. Right, so they sometimes Karl Veshak can bring floods also, because sometimes the rainfall can be so very high that in Assam it can bring floods. So that is how it has an overall, these local winds have an overall effect on the life and livelihood of a local condition. But understand that there can be so many local winds. There are like hundreds of local winds. We have just hand-picking 4 or 5 so that we can write in our answers related to local winds. And I suggest you must remember the example of these local winds. It's very, very essential. You have a question in exam which is define local winds. That means not many people will be prepared for such exact question, right? Okay. Now we come to the question which is explain the interconnectedness of global climate system with suitable examples. Global climate systems. What is meant by the global climate system and what is this all about? How do we come to know about it? You know, IPCC, Intergovernmental Panel for the Climate Change, IPCC, Intergovernmental Panel for the Climate Change, in the second report, in the second assessment report, right, mentions this is global climate system, and the global climate system consisting of 5 components. According to the IPCC, they were explaining that these 5 components, global climate system, these 5 components should work in tandem, in balance, in equilibrium with each other to have the climatic significance, a climatic balance or equilibrium. So this equilibrium is not maintained only in the atmosphere, but also other aspects, other spheres on the Earth's surface. What are these? First, of course, is atmosphere. First component is atmosphere, right? The second component is Earth's surface. Earth's surface. This is a second component. Third component is cryosurface or cryosphere. That is ice, CRYO, cryosphere. That is ice cover. The fourth component is biosphere, and component that is hydrosphere. hydrosphere. Now, there is a constant interaction of Earth's surface and atmosphere, which is called as the lithosphere. There is constant interaction from hydrosphere to atmosphere. There is constant interaction between cryosphere and atmosphere. Constant interaction between all of these with the biosphere. So when we draw this interconnectedness is very deep. It's just like a web. It's deeply knitted or very tightly knitted, forming a web of interactions between the 5 components of global climate system. Let's go a little deeper, because the question is on interconnectedness, right? So now the question demands, so first strike this, that it was second assessment report published by IPCC that global climatic system was first discussed, and they talked about 5 components of the entire system, which is very important to strike balance on the surface of Earth. So the global interconnectedness of all the 5 components as explained. Let's start with atmosphere. Atmosphere, right? So you can see that any change or processes that take place in atmosphere, such as winds, right, play an important role in oceanic circulation. Right? Due to atmosphere, there is temperature difference at different latitudes, at various latitudes. Now, this temperature difference is actually regulated by winds or an intense air circulation. Planetary winds is a part of this intense air circulation, because this gives rise to the formation of different types of pressure belts, and in the different types of pressure belts there are different aspects also that is considered. And for example, like pressure belts give rise to the planetary winds, and they carry warm air masses and cold air masses. Warm air masses from tropical areas to the polar areas, from cold air masses from polar areas to the tropical areas. At the same time, they also bring changes in the hydrosphere, isn't it? Changes in the hydrosphere. And all this hydrosphere does is the oceanic currents dissipate heat to higher latitudes, right? Dissipate heat to higher latitudes and also ensure distribution of, that also plays in distribution of flora and fauna. Also played an important role in biosphere and all that. Now coming to the third aspect, like lithosphere or the Earth's surface. Now on the lithosphere there is soil. Let's start with the soil. And you know, the soil is something that fascinates me a lot personally. I'm saying this. It's because, just try to understand soil. It is an interface. We'll not write the definition. We are just writing something different about soils. Interface where all spheres actually meet. Soil has a component of atmosphere. There is oxygen, there is gaseous concentration of soil. Soil has a component of hydrosphere. There is moisture present in the soil. Soil has a component of lithosphere because there are different minerals in it. Soil has a lithosphere, soil has a component of biosphere because it has organic content in it, right? It has organic contents in it. So you can see all of these regions are somewhere interacting in in soil. The gaseous concentration like nitrogen content, oxygen and other content also present. Water is present, that moisture is present because that hydrosphere involves all the processes that we see, whether it's, whether it's the fresh water or the saline water. Then we talk about organic content, so it represents biosphere also. So all these sphere, it has minerals like potash or phosphate or any titaniferous minerals or any minerals. That's because of lithosphere. So here all of them jumble up, they all get here. And it is also the region where inorganic becomes organic. Inorganic becomes organic. That is, non-living becomes living. That is what is in the lithosphere. That is what is so important about the soil aspect. So this is how lithosphere. Then we have another component, that is the cryosphere. Fourth, cryosphere. Now the cryosphere is ice cover, right? Ice cover, and has maximum albedo. Has maximum albedo. That is, it reflects sunlight, right? Reflects sunlight, right? Sun rays, and helps in the temperature regulation. Temperature regulation. Not only that, cryosphere is also very important to maintain the sea level, right? It also maintains the sea level, right? So not only plays an important role in atmosphere, it also plays an important role in maintenance of hydrosphere. And where all this is happening and having influence on the biosphere, yes, we'll write. So we can write in this way, that if the height of the mountain increases, the speed of the river also increases, right? And the temperature increase, with the increase of this, the temperature decreases, and there's a presence of ice cover over it, and this all runs to the hydrosphere. This all runs to the hydrosphere, right? Collection of water. Now, due to the evaporation, it influences the heat transfer of heat in atmosphere, which somewhere influences rainfall, adds up to the hydrosphere, causes erosion. So all this forms a continuum of functions, continuum of the components. Hydrosphere, there's oceano-atmospheric continuum. Let's take an example of these one by one. So this is just how continuity they maintain and how do they work. Global climate system. Oceano-atmospheric continuum. Example is El Nino. Example is Madden-Julian oscillation, right? Madden-Julian oscillation, they are oceano-atmospheric continuum, right? Now here we'll write the same continuum with the surface, Earth's surface, continuum with the Earth's surface. This continuum can be seen very well in Himalayas, right? Himalayas, that it influences monsoon. The Tibetan plateau influencing monsoon by creating this masculine highs and other aspects. So all of them are forming one continuum, and rainfall automatically helps in the development of biosphere like plants, right? How do biosphere helps? Because it is important, the only like plants from where the sunlight enters the food chain, decomposition of these organic minerals can further mineralize this lithosphere. So there's a continuous cycle. You can take few examples, one by one example, and continuum. Like if you have to find the Earth surface biosphere and Earth surface continuum, that can be formed by cycle of nutrients, right? Nutrient cycle will tell us how the continuum is formed, right? So all these phenomena can be related to each other, and this, now how to conclude this topic? Now this, it becomes difficult in exam, because we are supposed to write so many things, right? We are supposed to write so many things, like on one side we are writing lithosphere, on the other side we are writing cryosphere, we are writing some other aspects like biosphere and all that. So giving interconnectedness is not so easy. So give examples, take example where you're talking about ocean and atmosphere, take an example. Lithosphere and atmosphere, take an example. Himalaya as an example. Lithosphere and hydrosphere, of course, again the continent is in lithosphere and hydrosphere, that is from the glacials which act as a storehouse of water that is present on the continents, and it flows to that. Cryosphere and other surface, cryosphere and atmosphere, we can easily mention that, because cryosphere plays an important role in albedo and also maintains the sea level. Cite some examples to it. And soils, you can probably complete your interconnectedness on soils, that it is that surface or that interface where all these components are getting mixed, right? So soils, you can finish. Conclusion, as IPC said, there's that balance in all these, all components is significant for human survival. For human survival. That is how you can address this. Okay. So now this brings us to another question from oceanography. So see, the questions that we are expecting in climate would be something like planetary winds and winds, local winds, which has not been asked, frontogenesis, which has not been asked, and something related to the climate and climate change, whether it's an anthropogenic phenomena, how are different components of climates getting disturbed. Climate change will also be the part of environment ecology, so this can also be a question asked there. How climate change, the problems that we have in climate, or whether it's natural phenomena, what should be taken care of, and the new meets climate summits that have been taken, that can also be asked in paper 1 in the climatology. Nothing so surprising about it, right? There can be questions there. And one question was asked, significance of cryosphere in maintaining the temperature. It was basically a part taken from the same discussion, global climatic system and all that, because it has a very high albedo, maintains in the heat budget, plays an important role in the heat budget, and apart from that, it is also covering huge amount of methane that is present in the deeper layers of Arctic Ocean and in the polar areas. So unlocking the methane can trigger climate change or can accelerate the climate change, because of the fact that methane is more potent in climate change than other gases. So that is also one of the role of cryosphere, that it has locked methane, it is not allowing it to come out. So that is one of the role that we play. It also maintains sea level, that we have already mentioned, and that's quite easy to understand, right? Okay, coming to the next aspect in oceanography, See, the question can be asked on two fronts, two broad aspects. One is the question asked in temperature salinity distribution. Salinity distribution has already been asked, so we expect on temperature distribution. We also expect that in oceanic circulations, ocean currents. I think question has been question has been asked on ocean currents, that what are the different factors affecting ocean currents? How do they play an important role in navigation, fishing and trading? So that is also one of the questions that we expect. But since these questions have been already asked, so we are trying to mix up questions. It is temperature, salinity and density difference in ocean waters are prime cause of oceanic circulation. Elaborate. First of all, temperature, salinity and density difference. So temperature difference, right? Temperature difference. How do they lead to the? First point we will be focusing on, not the introduction though, but we will be focusing on temperature variation in oceans. Variation in oceans. So there is horizontal and vertical variation in temperature, right? Horizontal and vertical distribution in of temperature, or variation of temperature. So the horizontal variation of temperature is due to sun rays, primarily sun rays, right? In polar areas the temperature is low, right? Temperature is low, and in tropical areas the temperature is higher. Temperature is higher. Vertical distribution, the surface temperature is high. In the bottom, temperature is low. Temperature is low because sun rays cannot penetrate up to that region. So largely the sun rays, distribution of angle of sun rays or the reach of the sun rays determine the temperature and temperature variation in oceans. This is one point that we understand. Second is about salinity. Salinity. Multiple factors play an important role in salinity, like oceanic circulation itself, wind movement. There are phenomena like the distribution of land mass, influx, etc. But more importantly, it is evaporation and precipitation which guides or which describes salinity, that plays an important role or determines salinity. How? We have a low salinity in the polar regions, we have higher salinity in the tropical areas. So something like that, right? First of all, you understand this. And also the surface salinity and bottom salinity. There's variation in the surface and bottom salinity, right? Surface salinity and bottom salinity varies, there's variation between the two. Because of that variation, right, there is density difference. So if the temperature is different, salinity is different, obviously the density will also be different. So what are we trying to understand here or trying to explain here? That there are different factors leading to the difference in temperature and difference in the salinity of oceans. Mention this. How does it lead to the oceanic circulation? We know that we can write that water movement occurs from low salinity to higher salinity. Low salinity to higher salinity. This causes, that's because of osmotic movement Although we don't write osmotic movement because we might have get confused that there's semi-permeable membrane in between or something. Nothing like that. We'll just write about that there is a movement, water movement from low salinity to higher salinity. For example, from polar regions or subpolar regions, water movement is towards low latitude regions. Why is it so? Because here the salinity is low in polar areas, salinity is high in the low latitude regions. Name of such currents like East Greenland current, Oyashio current, Labrador current. So be specific that Labrador current and East Greenland current are in Atlantic Ocean, Oyashio current is in Pacific Ocean. So be very specific here that these are the Atlantic Ocean currents and this is the Pacific Ocean currents. That happens in that water movement from low salinity to higher salinity. Also, temperature variation plays an important role. How does temperature variation play an important role? That warm water expands towards colder regions. Also in subpolar latitudes, right? The cold water being denser, sinks to deeper layers and maintains lower water level, right? Lower water level. So what happens is water level in subpolar region is lesser, water level in the polar regions is tropical areas is higher. So there is a warm water to cold water movement. So there's a water movement that goes from equatorial areas to the subpolar regions. So we'll write, for example, Gulf Stream in Atlantic Ocean, or Kuroshio current in Pacific Ocean, right? Kuroshio current in Pacific Ocean. These are because of the temperature difference between tropical areas and subpolar regions. So the water movement happens from these low latitudes to the high latitudes because of this temperature difference. So that is how we can relate to this movement. Now we will write one more line here and then we'll go to the next aspect of the oceanic circulations. We can write about it that there are other factors also. You must write this point that other factors such as winds, right? Such as winds and coastlines also affect oceanic circulations. This is also one aspect. Now, so far we have discussed only the surface circulations, that what happens from the Kuroshio current going from equatorial areas to subpolar areas, or Gulf Stream moving from equatorial areas to subpolar areas, or cold currents or fresh water to low salinity or low saline water conditions. They move from low saline to high salinity conditions. So this is one aspect. Due to the temperature and salinity and density difference, there is also deep ocean circulations. Deep ocean circulations which are formed. These deep ocean circulations are also called as thermohaline circulations. They're only and only because of the change in the density and temperature of the oceans. There is no other reason for the formation of these thermohaline circulations or deep oceanic circulations. Surface is because of winds and other factors. Temperature plays an important role. There's an expansion. Temperature difference plays an important role. There's an expansion of warm water towards the colder areas because water level is lesser here. So from warm regions, it goes to the subpolar regions. One. Second, we can also write about it that salinity difference from the fresh water comes to the low regions. Now, you need to mention about this particular topic, thermohaline circulations. And there is one contemporary aspect to it, thermohaline circulation. So, this is, suppose we'll write that it is equatorial areas, suppose these are subpolar regions. These are subpolar regions. You can draw the diagram there in exam. And this warm water reaches to the subpolar regions where the temperature is low. It also carries salt to the surface, also carries salt to the subpolar areas. So you can write that increase in salinity and low temperature increasing density, increases density. So less temperature, higher salinity, increases density. This causes subsidence or sinking of water to the deeper layers, and such circulations are called as thermohaline circulations. These are called as thermohaline circulations, or what is also called as, example to this, examples we call it as North Atlantic meridional circulations. They can be North Pacific meridional circulations also. But since they come to the polar areas, sink, they are also called as North Atlantic overturning meridional circulation. Right? Atlantic meridional overturning circulations. Overturning circulations. You can take an example of it's thermohaline circulations. Atlantic Ocean goes to the currents in the Atlantic Ocean go to the north, they become dense, they sink and come back. Pacific Ocean, they go to the polar areas, they become cold, sink and come back. In North Indian Ocean, it is not there because Indian Ocean is only to the tropical areas. That circulation doesn't happen so much. That that sinking of water doesn't happen so much. So you can take examples. Recently, it was in news. North Atlantic meridional overturning circulation was in news some two years ago, and it is still in news. It said that due to melting of ice, these have slowed down. North Atlantic meridional overturning circulations had slowed down. You will write this. Why? Because the melt of ice reduces salinity. It's a fresh water, and that further decreases density. Right? Density of water. If the density of water decreases, this will not sink, and if it does not sink, this will have an influence on the slowing down of circulation. So this can be a separate question in your exam. What are Atlantic meridional overturning circulations, and what will be its long-term influence? Something like that. So why are they slowing down. They're slowing down because more and more fresh water is getting added to the Atlantic Ocean. So adding up fresh water decreases salinity, decreases density, so water doesn't sink at 60 degree, it remains on the surface. If it doesn't sink at 60 degree, it may not rise from the other end also, right? So sinking of Atlantic Ocean in the water in the subpolar regions and comes from the equatorial areas. If sinking doesn't happen, it may not rise with the same intensity, slowing down the Atlantic Ocean meridional circulation. This is purely case of thermo-haline circulation. Thermo means temperature, haline means salinity. So the circulations caused by the thermal and salinity difference. Two dimensions to it, this question. One dimension is the surface temperature that we'll write, and then this. Now, how do we write this in answer? So much of information, how do we write in our answers? First paragraph, you should write about the temperature changes with latitude and depth, because of the difference in angle of sun rays, and water as full stop, ऐसे करके, water being translucent, sun rays can penetrate only up to the photic zone. Photic zone means the zone up to which sun rays can penetrate, that is up to 200 meters. Right? This is the temperature change. Similarly, I can also write salinity is also determined by many factors such as influx of water, distribution of continents, etc. Right? Both variation, now we'll write variation of temperature and salinity causes water or ocean water to move. Why is it so? Why is it so that temperature and salinity difference causes water to move? Because nature loves balance. If you don't want to write like nature loves balance, you can write the natural processes occur to strike balance. This is what we are supposed to write here. And once you write about it, come to the examples that we have already mentioned here. We have already mentioned that water movement from low salinity to high salinity. Quote examples. Temperature salinity difference from low salinity to high salinity. Give the examples. High temperature to low temperature. Take examples. After that, you mention about this thermohaline circulations also, that deeper oceanic circulations can occur because of temperature difference. Next, right? So this will cover 2 points. One is the temperature difference. You must also prepare for temperature difference. So account for the variation of temperature difference in oceans. Horizontal temperature difference and vertical temperature difference. Maybe if they can ask question on salinity, they may also ask question on temperature. Ocean currents, I suggest this to everyone. You take any UPSC exam, In oceanography, the most significant topic is ocean current. Prepare ocean currents in detail, factors affecting ocean currents, the effect of ocean currents on the local water bodies, trading, navigation, everything about it. Right? You should be thorough with that, important. Then comes this last question we have chosen is ocean warming has caused coral depletion via bleaching as well as the deadly outbreak of diseases examined. Right? Ocean warming has caused coral reef depletion via bleaching. Yes, it has. So we must write something like that corals are ecologically sensitive, that is why, right, thus also referred as ecological indicators. Ecological indicators. Something like that we'll write first, that corals, due to the ecological sensitivity of the corals, they are called as ecological indicators. Right? What is it? In next line we are going to write that any change in the climatic in the oceans, any change in oceans have an influence on corals. It can be detrimental influence, it can be positive influence. Global warming or increase in temperature, something like increase in temperature being the most common or adverse. Common says other, you can write adverse. Adverse ocean warming. So we are addressing it that ecologically sensitive change in temperature is causing adverse effect. Now we'll write how is it taking place, because there's a question on bleaching, so we must also explain bleaching here. So we can write that the symbiotic relation between corals and algal filament, and even if you're not writing algal filament, we'll write zooxanthellae, right? Zooxanthellae, zooxanthellae. Which are zooxanthellae? Those organisms, those plants which live in symbiotic relation with the animals. Zoo means animal, xantha means pigment. So pigmented organisms which live in symbiotic relation with animals. So which are pigmented organisms? Right? Pigmented organisms, nothing but the plants. So red algae, green algae, brown algae, all green algae, all these things. Symbiotic relation with corals and zooxanthellae. Okay, mention about it, we'll stop. So you can write symbiotic relation between corals and zooxanthellae gets disturbed, right? Disturbed, leading to the loss of zooxanthellae. They leave the body, making the coral colony decolorized, thus symbolically called as coral bleaching. What is process of bleaching? The decolorization is called as bleaching, right? If anything loses color due to some reactions or something, that is called as bleaching. So here coral bleaching happens. Why? Because the zooxanthellae, which imparts color to the coral colony, leads the coral colony. As it leaves the coral colony, it starts getting decolorized. So that is how we term this coral bleaching. Now, one of the main reasons that, so what we have tried to do here, we have tried to understand corals and also define bleaching. Right? Now coming to the main point. Main point is global warming that leads to the changes. You know, there have been reports. There was one report called as Clive-Wilkinson report. Clive-Wilkinson report that explains, it was although very old, like 1998 it had given the report, then it was again in 2004. It said that El Nino and abnormal heating of oceans have led to the mass coral bleaching. The coral destruction on a mass scale has happened because of this El Nino undercurrent, which is a warm current heating of this. So this also repeated in 2014, this also repeated in 2015, and we say that it is because of the global warming or ocean warming that has happened. One of the reasons for this ocean warming has been attributed to El Nino. It is because of this strong warm water current that spread in the Pacific Ocean leading to this, and Clive-Wilkinson report was the first that related the coral bleaching with the ocean warming. Coming to the next point of this reason for the coral bleaching and another example of warming, that's also because oceans are becoming heat sink. Oceans are becoming heat sinks. Why are they becoming heat sinks? Because water can absorb more heat and can retain the heat for a longer duration of time. So heat sinks, oceans are becoming heat sinks, so can retain heat for longer duration. That is heat sinks. Come to the next aspect. Very recently, this corals were studied in Great Barrier Reef. A recent study in Great Barrier Reef. There 500 corals were identified, right, studied. 500 corals were studied, out of which only 4 did not experience coral bleaching. That means 496 coral islands which were studied in the Great Barrier Reef have out of 500 have experienced coral bleaching. So this report you can write, this finding you can write in your answers, that out of the 500 coral islands studied in Great Barrier Reef, only 4 did not experience coral bleaching and rest did experience coral bleaching. It's because of heating effect. 2 reasons for the heating: El Nino and the oceans becoming a heat sink. Okay. Now one more aspect is because the increased carbon dioxide concentration in atmosphere, it reacts to water and forms this carbonic acid, H2CO3, carbonic acid. This carbonic acid reacts to the coral shells, which is composed of calcium carbonate and causes the corrosion. So we'll not write this reaction. No need to write reactions in any answer. You can just write that the carbonic acid formed or ocean acidification is leading to the corrosion of coral exoskeleton because it is composed of calcium carbonate, and that exposes the coral body. Hence subjected to a lot of diseases. One more aspect is oil spill. You can add that oil forms a thin film on water and corals suffocate to death. And that is also one of the reasons for it. And then towards the end you can write measures that can be taken, that is reversing measures that can be taken. Like what can we do here? Reversing the climate change, reversing the effect of the climate change, and so that corals can be protected. So there is coral watch team in Australia and many parts of the world, including the Pacific Ocean and Indian Ocean. So that is one of the way to reverse. So measures should be written, the steps that can be taken to prevent corals and coral reefs. This is important. And you also will write that they are biodiverse, and to preserve the biodiversity of ocean habitat, the coral is extremely important. We must preserve coral and so on. Now this is the last discussion that we have for oceans. One more aspect is there associated with it, that is coral, that is the resources of oceans that we'll discuss in resources topic. So far this is all about oceans and physical geography. See, we wish you good luck with it. I hope you can get broader idea about physical geography. So this is what we felt is important. Apart from that, I would just suggest and urge one thing. In this entire discussion, I did not focus much on the structuring of the answers so much as we focus on the concept. Well, I believe that this exam can be cleared with a very strong content. So my suggestion, and I always suggest everyone, that please work on the content. If you have content, that is always as an advantage, that is always a confidence. Then content can be organized in the most preferred manner and the most suitable manner, so that the flow of the answer is maintained. That is, examiner, when he starts reading the question, reading your answer, the flow should be continued, the flow should continue. That is what we focus upon. So flow will continue, of course, if you have read properly and if you have enough content with you. In the topics tomorrow, we'll be moving towards the next discussions on human geography aspects, Indian aspects, and then other topics which are more applied. Here it was mainly based on the concept. Content, tomorrow the content will change towards more applied aspects, right? So I wish you good luck and keep preparing. I'll see you tomorrow at the same, that is 10:30, and if you have any doubts you can always put forward. Thank you.